says it's not recording yet. There's a high probability I'm just standing here awkwardly while it is recording, though. All right, if you are watching this video in spring of 2022, then I am on page 82 of your purple book. If you're watching this video at some other time, don't know. You're going to have to figure that part out yourself. At the very top of this page, we have a simulation that we're going to do first. If you're watching this on YouTube, then I'm going to put the link to the simulation in the video description. And you'll be able to open that separately and look at it alongside what I'm doing, because you're going to have to actually fill in that chart using this yourself. So what you're going to do is when you open the link, you're going to click on Introduction. And then you can select strong or weak, acid or base, as well as being like versus water. From there, you can fill in this little chart as far as the pH information goes. So the name part you need to do yourself as practice using like the naming rules that were in that flow chart from my previous video, which again, if you're watching this in spring of 2022, that was on page 78. Yeah. So then the name part, you're going to have to do yourself as practice, and recognizing if something's an acid or a base, you're going to have to do yourself as practice. But once you get that far, being able to do strong or weak in the pH and the conductivity, that's going to involve this simulation. So like if I know something is a strong acid, which you're being told in the chart, it literally tells you strong or weak, put in the pH meter, and its pH is going to be 2. So anything that you pick as an acid that is also labeled in the chart as strong, you're going to put a pH of 2. For conductivity, click on the light bulb. You can drag the cathode and anode into the solution, and you'll see if it is bright or if it is dim. And then you can write bright or dim in the conductivity part of the chart. So you're supposed to use this simulation to fill in the chart at the top of page 82. So I will do one example with you. This very first one, there we go. HCl, I see that it starts with an H, which tells me that this is an acid. I'm not going to name it for you. You still need to go name it yourself as practice, okay? But as a strong acid, when I put the pH meter in from that simulator, the pH meter for a strong acid has a reading of 2. So I'm going to put a pH of 2. When I put the light bulb in the simulator, it was bright. So I'm just going to label it bright. Okay. You need to pause this video and fill in the rest of this chart yourself using the flow chart on page 78 to write the acid and base names, and then using the simulator to figure out the pH and the conductivity. Pause this video, do that, and then come back and press play. Once you have filled in that chart and you have pressed play on this video again, we're going to fill in some blanks. So acids contain the H at the beginning. It's technically an H with a positive 1 charge. So they produce hydronium, which again is that H3O plus ion. And they also produce an anion. Remember, anions are negatively charged. Bases contain hydroxide, the OH minus, and they produce that hydroxide. Again, the OH minus is hydroxide. And they also produce a cation, cations being the positively charged ones, right? Cats are positive was our memory trick back in November. it talks about protons here. I want to take a little time out for what we're saying when we talk about protons. If we think about a hydrogen atom, which when you check your periodic table has an atomic number of 1, that means you got 1 proton and it is surrounded by 1 electron. But when that electron is lost in a chemical reaction, you take away that negative electron, and then you're left with literally only a proton. So if hydrogen atoms undergo a reaction where they lose that electron and it goes on to some other atom, then that means you're losing that electron, losing your negative charge. You're left with only that 1 proton. So it turns out that a hydrogen ion is the same thing as a proton. We get these protons because a hydrogen atom lost an electron. So when we talk about protons, we're also talking about the hydrogen ion concentration. And we symbolize that by putting these square brackets around the proton or around H3O plus. They mean the same thing. So the square brackets mean concentration. That's like an abbreviation, a shorthand for concentration. So if we know the concentration of protons, that would be H plus in square brackets. Or we also know that when an H plus finds a water molecule, they join together, right? And that's where hydronium comes from. The 3 hydrogens come together and you have this positive charge and you still have the oxygen from the water in the first place. So those end up being the same thing. Your concentration of protons and your concentration of hydronium end up being a 1-to-1 ratio. So they're the same number. So we end up using these abbreviations interchangeably. If you know the concentration of protons or if you know the concentration of hydronium, you can calculate a pH. With this formula, your pH is the negative log of H plus or the negative log of H3O plus. Those brackets mean molarity, so concentration in units of molarity. I know some of you see the log and you're freaking out because you do logs in Algebra 2 and you hate it. And some of you see the log and you're like, I don't know what that is. I'm only in geometry. It doesn't matter. We're just pressing a button on your calculator here in chemistry. Okay, it's not a big deal. Either way, what happens is when you have a high concentration of protons, that ends up being a low pH, which makes it more acidic. The concentration being high makes your pH low. That is just sort of the way that the logarithm math works. And I want you to not worry about that because I'm not a math teacher trying to make you understand logarithms. I'm just telling you this is how it is. A high amount of H plus means a low pH. And all in all, that makes it more acidic. The pH literally stands for power of hydrogen. So we're talking about the powers of 10 in the pH scale. So like your power of hydrogen when it's -1, that ends up being a pH of 1. When your power of hydrogen is -2, you get a pH of 2, so on and so forth. Again, don't worry about how that works with logarithms. You can learn that in Algebra 2. I'm just telling you this is how it works. And that's how things are going to be. So when you have a basic solution, you end up having a pH that is greater than 7. Or when you have an acidic solution, it ends up being less than 7. Neutral solutions are pH equals 7. So that would be like pure water. This basic idea, pH greater than 7 is a base, equal to 7 is neutral, less than 7 is an acid. That comes from how these pHs are calculated. So we're going to practice calculating them using a calculator. Please do not feel like you ever have to do this without a calculator. You can always do this with a calculator. Your pH calculation is just this formula right here. These are the buttons you press. You hit the negative, you hit the log, and then you type in your number that you've been given for the concentration. Okay, don't overthink it. So when they give you a number as a concentration, what you are typing in your calculator, you are going to hit the negative button, right? Negative, make sure you're hitting negative, not subtraction minus, negative down at the bottom. Hit the negative button, hit the log button, okay? Log, hit it so that your screen looks like this, although it's probably flipped, whatever, you can figure it out. And then you're just going to type the number, okay? So that number says 4.92 times 10 to the negative ninth. Remember, we're using the E button for scientific notation. So what you're literally typing, here are the buttons you type. You hit negative, you hit log, you hit 4.92, and then to get the E, you're going to hit second and then comma. That'll get you the E. The E stands for exponent. Now you just have to type the exponent, which is a negative 9. So if you are typing it correctly, it should look like this. Okay. And then you just press enter. And it says my pH is 8.308034, blah, blah, blah. We're going to round to the hundredths place. So this is 8.31. Okay. There's also, whoops, I totally skipped it. There's an example up here that they said, what is the pH with this number? So you would hit negative, hit log, type 5.32. To get the E, you're going to, again, use second, comma, and then hit your exponent is negative 2. So then you just type negative 2. Negative log 5.23, second comma gets you the E, negative 2, and your pH comes out to 1.28. I highly encourage you to pause this video and type those two problems yourself and make sure you get the same thing that I got. Because if you're getting a different number, you're typing it wrong, and that's going to cause you a lot of problems. Pause the video, type those two yourself, check yourself. Once you have checked yourself, what we're going to do is we're going to figure out if these are acids or bases by comparing these numbers to 7. So 1.28 is less than 7. 8.31 is greater than 7. Less than 7 is an acid. Greater than 7 is a base. So 1.28, the example, less than 7, tells me that that one is acidic. But 8.31, the first one in the chart, that's greater than 7. That tells me that this is basic. Okay, at this time, again, pause the video and try number 2 and 3 yourself. And after you try number 2 and 3 yourself, unpause the video and check yourself, because I'm going to put the answers in the video right there. Okay. Okay, I hope you paused. And now you've pressed play again after filling in these 2 rows yourself. Negative log of 1 times 10 to the negative 7 is 7. When your pH is equal to 7, that is neutral. And then negative log of 0.0023 comes out to 2.64. That is less than 7, so this one's acidic. Okay, again, pause the video, try this chart yourself, then press play. I'll put up the answers real quick. Pause the video and try the chart yourself. Okay, at this point, you've paused, you've done this chart, and now you're pressing play to check yourself. You should be checking yourself. You should have already filled in this chart if you're obeying instructions, okay? Check yourself in a chart you've already filled in. This pH is 8. That's greater than 7, so this is basic. I'm just going to start breathing. Negative log 0.0038. This is 2.42. That is less than 7, so this one's acidic. Negative log 5.37. E, negative 5, 4.27, that's less than 7. This one's acidic. This one is 7, that's equal to 7. That's neutral. And negative log 5.11, E, negative 13, 12.29, that is greater than 7. That one's a base. Keep in mind, your acids contain hydronium, H3O+, that's the same as H+. Your bases contain hydroxide. Hydronium and hydroxide are opposites, but anything dissolved in water is going to always have at least a little bit of both. It'll have more of one or more of the other, but there's going to be some of each in there. So when there is more hydronium than hydroxide, you know that the solution is an acid, okay? And when there is more hydroxide than hydronium, you know the solution is a base. If you find a solution where your hydronium and your hydroxide are equal, then that must be a neutral solution like pure water. So all in all, this little chart, very helpful information right here. It's not really a chart, but this little paragraph, whatever. Acids have more hydronium or more protons and less hydroxide. Bases have more hydroxide, less protons, and less hydronium. If it's neutral, that means they have the same amount of protons or hydroniums, same as hydroxide. So when you look at this chart on the next page, at this point, I have now moved on from page 82 to 83 and now 84. If you're watching this in spring 2022, I'm on page 84 now. When you fill in this chart, to find the pH, you're still going to do negative log of whatever the hydronium concentration number you've been given is. Okay, so negative log 8.32 E negative 10. That gets me a pH of 9.08 is what it rounds to. That's greater than 7, which tells me that this is a base. And what is there more of? If it's more hydroxide, then it's a base. If it's more hydronium, then it's an acid. So this one was a base. There must be more hydroxide. Okay, that's the way you do this chart. And that's it. That's pH. It's not so bad, right? Enjoy.